we're now here to kind of take you through the other kind of side of the DevOps picture here, right? So David kind of covered that DevOps for the data infrastructure. Well, we're going to say, well, at the other kind of almost at the other end of the maturity spectrum now, for the DevOps side, this is saying, okay, well, we now have these newfangled things, right? These newfangled machine learning models. We've got a team who's built some, right? We've got these things, they're ready to go. But what do we do with those, right? Once they're ready to go, how do we production? How do we keep them there? How do we make sure they aren't going off the rails? So we're going to talk you through some of that today. This, I want to emphasize this is a really emerging field, very emerging. A lot of what we'll talk about today is like less than a year old. So you might read other things might have different names and things that you'll read. What we're going to talk about here is what's becoming what we think is the industry standard definitions for things. But where we can, we will point out other verbiage that you might have heard or might have seen kind of from this field. And we are recording this. I believe the recording is already on. And please, if you have questions, put them to the chat on the sidebar. We will answer them at the end of this talk, as David did on the previous one. All right. So we'll talk about today. First up, I'll talk about what is MLOps, right, and why is it challenging? Why should we care about this, and how is it different? Why do we call it MLOps rather than DevOps and machine learning, right? Why does it have its own name, and why is that important, and why is it a challenging thing to do? Why is it so new? My colleague Ron will talk about MLOps from the technical perspective. He'll do a deep dive on a few aspects of this. This is a deep topic, and so we will surface level this, but hopefully you'll find that interesting. And then Echo will present a demo, which she'll kick off and show at various points about how to do continuous retraining and continuous deployment of machine learning models. Brief intros. My name is Lee Harper. I'm Catapult's principal data scientist. I lead the data science and machine learning engineering capability at Catapult Systems. Ron?
Yeah, thank you, Lee. I'm Ron Joy. I'm the data platform technical team lead on the data and AI practice. That's what that means in English, is everything except the data engineering and the data science and all the fun, innovative things. I help support them with DevOps and infrastructure and some of the kind of app dev components that are related in order to let them do all the fun things, all the data science, all of the data engineering.
Echo?
Hi, I am Echo. I am an intern, so a lot less to say there, not as much of a mouthful. I'm also a computer science student. So.
And Echo's been fantastic about actually helping us build out a lot of our assets around this. She talks herself down with being an intern. She's been a fantastic resource for us. So thank you, Echo, up front for all the work you've done on this. Okay, so what is MLOps and why is it a challenge, right? Why is it a new field? Why isn't it, as mature as normal traditional DevOps? So here's how I kind of put things, right? It's a bit kitschy, but I think it's quite effective. If I don't say it, then I know that Ron will say it. Data scientists are like pirates. In general, we're hired because we're great problem solvers, right? We can solve business problems, generally quite well using AI, machine learning, or other tools. And we're good at using a range of technologies to solve these problems successfully. But one, we can often get siloed, and generally speaking, we lack the detailed engineering skills because often we come from analyst backgrounds or academic research backgrounds. And so when we push into production, often they end up being held together with sticky tape and glue. Okay, so we're pirates, right? We get things done, but they're often messy. They're not always very structured. And in production, that's a problem, right? Because companies function like navies. Okay, this comes back into this data culture thing, right? Those pirates, they have no culture. They have almost no data culture at all to speak of. Companies, especially who are using AI and machine learning, have reasonably or want to have mature cultures, and that's like a navy. So building a production model is highly cross-functional, right? You've got a range of different people, so different ships in this case, all working together to do more than any one person could do on their own, right? Really, no single person has the skill set to do all this on their own successfully. The idea of the MLOps engineer, quite frankly, being one person is kind of an in-joke right now. So these disciplines working in concert towards this common goal really creates this team or this capability, this kind of cultural asset, if you will, that's really more than the sum of its parts, considerably so. So how do we take our data science pirates and really turn them into like the company navy? And this is the technical track. So I want to first clarify a definition for you, okay? You'll hear us talk about machine learning models quite regularly in this field. And indeed, some companies call this MLOps rather than MLOps. From the technical perspective, when we talk about a model, what we really mean is there's data, there's code. Our code uses data to build a serialized artifact file. Okay, in Python, it's called a pickle file, is a very common format. There's an ML flow format. There's a format called Onyx that's becoming cross-platform. But really, a model in this context of this talk is that serialized artifact, nothing more and nothing less, that's built from code and built from data. Okay, so kind of bear that in your mind as we go through this session. That's what we mean specifically here. There's obviously more detail to all these things, but they're less relevant for this topic. Okay, so what is MLOps? Right, I've used this term 10 times already. What is it? The pithy answer people often give is it's DevOps machine learning, but that's to me incomplete. DevOps is absolutely must be followed as part of this effort, but there's more to it than just that. And kind of tying into our data culture thing of people, process, and tools, it's the practices really, the process that enables that collaboration between data, software, and ops teams, the people, to help manage the machine learning model lifecycle. And that lifecycle looks like this, right? So typically we have code check-in, okay, like any build process that we do in app dev. We then get a data set. We then train our model. That's this synthesis of code and data to build this artifact entity we want. We've then got to deploy that model alongside its code that it needs to run to some kind of infrastructure. And then we need to, especially in real time, serve data that we have to get predictions or inferences on to that infrastructure. And at some point, we'll have to update the model. Okay, data doesn't stay the same. Data, as we'll talk about later, changes. It's not a stable entity. With code, if the code doesn't change, okay, there could be bugs in it, but it won't. What it does won't change. Okay, code does what code does. It's the set of instructions. Data in real time changes, right? It evolves. It does not stay static. So the same code might be working fine, but the data has to be updated at various points. And hence we have on the left-hand side there 2 arrows. The cycle here might be entered into by a code check-in, right? We've changed our algorithm, we've fixed the bug, or it could be kicked off by our data changing. So not only do we have 1 entry point here, we have 2 entry points for kicking off this process that is needed to make this stuff work. And that'll be something that we come to again over and over in this talk. Is it a code check-in or is it a data change that kicks off our update? So why is this challenging? I've already looked at this once before. This is how do we get the right skill sets into play? Code check-in, well, that's DevOps, right? All that good stuff there, with code, unit testing, that's all the room of DevOps. Well, getting our data set, well, that often requires either a good database administrator, data engineering to provide that data to us over the right location. Model training is the realm of the data scientist. Infrastructure, well, that's like David Vanderslice we just heard from, right? That's the kind of stuff that he works on it in a lot of detail. Getting those inferences live served, processing stuff in real time to hit the model requires good software engineering skills. Or if the model is part of a bigger application architecture, again, that's all the realm of software engineering. And then model update, well, that's everybody. And I would be, if you can show me a unicorn person that truly has all of this skill set in one package that's good enough to do this well, I would love to meet that person and buy him a drink. Or maybe give him a lot more than a drink, because I'm pretty convinced that that one person doesn't exist. This really is but do you have all these skill sets in one place? Because often at organizations, they're siloed. You have the data science team, you have the DBA team, you have the DevOps team, the infrastructure team, whereas here you have to have them all on one team working in concert, being that mature cultural navy. Challenge 2 is just the level of orchestration required here. Okay, we have to orchestrate so many things here. We've got to orchestrate code and these model artifacts. Like, how do we version these things? Right, I might have version 1 of my code. I might have 10 updates of that through data changes before my code changes. Right, how do I go about versioning that? How do I source control that? How do I roll back to an earlier version when my data isn't a static object? And then you've got the deployment side, right? You know, all the normal stuff you have for DevOps, the Docker files, dependencies, inference code, and endpoints, and how all those go together. So really, it's those extra things in the training that make things very complex for rolling things back and versioning and orchestrating things. And finally, the world is not static or deterministic. Okay, things can, and this is the big nasty in this field really, is that things can appear to be working fine. Your model is being served predictions. It's returning predictions. There's no bugs. Nothing is breaking. The world is happy. But no, that's not the case here, right? We have had a concept drift, right? Our input data changes. Black swan events, something random happens or big happens that changes the world for us. COVID-19 happened, and every data science model that predicts behavior suddenly had to be changed because now we're all behaving differently to how we were behaving before. Code could be the same, but the data's changed a lot. Models might be used outside of what they were trained to be used for, right? If I build a model to predict sales of something and I use it to try and run a marketing campaign, well, there could be some correlation there and it could make sense, but I haven't trained it to optimize for marketing. It's been trained to optimize for sales, and those are two different things, as Mindy, our CMO, will tell you regularly. Finally, unknown unknowns, right? Edge cases that we haven't predicted before, you know, new things that happen in the data that we haven't trained for in that model, right? So things can look fine, but unless we're monitoring the actual data itself and the inputs and the outputs of our model, as well as the infrastructure that runs it, we're going to be, you know, up a creek without a paddle. And to give you a more concrete example of this, make it a bit more real for you, COVID-19 changed everything, right? We all know this. It's a low-hanging fruit example. But in March of last year, the world changed very suddenly and very quickly, or at least in the United States. You know, state-of-the-art models in March. You know, we have models that do predict unemployment in the future. Those models in March would never have predicted April's unemployment. It just wouldn't have happened, right? That's an unknown unknown that the model could not have coped with. Then after it happens, of course, our behavior changes. We're now not traveling as much. We're now, you know, people have been laid off in their droves. People might have less money to spend, or we get a stimulus check and all of a sudden we have money to spend, right? All of these things, you know, have to be accounted for in your data set and in your machine learning model, and they weren't. But once they happen, you have to then change your model to account for that new data happening. And the big thing here is that MLOps, what Ron will show later on, allows detection and rapid response in a changing world. And that really here, right? It means that the limiting factor now isn't how fast we can get into production. Our sole limiting factor with MLOps is how fast can my data science team adapt to the new data, right? That's our sole limiting factor now in updating our models and our systems. And even 2 years ago, like, it was a nightmare doing that. I can attest to that myself from personal battle scars. So before I hand off, another key factor here is how do we empower without inhibiting? Okay, data scientists will say we're these pirates, and that's not going to change. So this process has to be able to deal with that piratical behavior and bring those people into the culture. How do you meet the data science team where they are? Okay. We have Azure DevOps or another Git repo, right, where we store our code. We should enable our data science to work in whatever pattern or whatever language they want to. So in Python or R, right, two really common data science languages, or Jupyter Notebooks, which is a common. It's not an IDE. That's a generous term for it, but it's a place where data scientists love to work. App dev people often hate it, and for good reasons. But how do we meet those people where they are, then to empower them with, you know, either batch serving or real-time serving of predictions? And the key here are these two connection points here, right? I have my code stored in Azure DevOps or in another Git repo. That's a universal point source of truth for my code. And if it's clear what the connection point is, if I allow my data science to work in Python or R or Jupyter or Julia or Spark or whatever they want to work in, what are the set of common artifacts I need to give them, or they need to give me as the MLOps person to package them up easily and work? And that's really our philosophy here. Is we want to build guardrails and a structure to bring those data science pirates into that modern data culture where MLOps is a necessary part of operations. So to summarize the challenge, no, go back. Okay, the three parts of the challenge really are the people, right? Man, how do we assemble the right crew, the right skill sets? How do we orchestrate components from many disciplines? And how do we monitor everything? Not only infrastructure and health of services, but also input data, predictions, and keep all that on track. So that's my brief intro, whistle stop to this topic. I'm now going to hand over to Echo, who's going to show you a little bit of an MLOps solution that we've put together to give you an idea of how some of these things work together. And then she's going to kick it off for you, and then Ron will take over, and then she'll show you the results at the end because models take some time to train. So Echo, over to you. You can take control of the screen if you want.
Hey, thank you, Lee. Okay, so far we've gone over some of the objectives of MLOps and the challenges that kind of come with it. And this demo is going to highlight the continuous retraining and the deployment phases of the MLOps lifecycle and what that might look like when applied to an actual project. So just to give you a little background on the data set that we used.
Are you sharing?
Oh, no, not yet.
Okay.
Yeah, I can share right now, though. But yeah, just a little bit of background on the data set that we used. Hold on, sorry. Multitasking is not a skill of mine, I guess. Okay. Yeah, so we used the Scania trucks. Scania trucks are in their everyday usage. It's a data set that aims to build a classifier with the goal of predicting whether or not a breakdown has occurred due to a specific component in an air pressure system. And this was chosen mainly because it's a good application of preventative maintenance, which is a really important metric that businesses hope to gain from models such as this one. So yeah, here on my screen, I have the YAML file, which is responsible for kicking off the pipeline, and that happens through Azure DevOps over here. So one of the early components of automating the model training and deployment process is getting all this stuff set up. So here in DevOps, we have our continuous integration pipeline YAML file. And this covers the training, the evaluation, and the registration of the model. So it does a lot of the heavy lifting. And this pipeline is triggered specifically whenever there are any code changes to the master branch on GitHub. And this is really nice because data scientists don't have to be confined to one platform to manually deploy whenever there's any little change to code, which can be cumbersome, and lots of things change very often, especially with data science, wherever that's concerned. And in our case, the triggering files are these two branches, which are this build training file and this run train pipeline. So the build training is a Python file. It's meant to act as a wrapper around existing training code. This was done on purpose. The intention was to make as little changes to the actual training code as possible. so it kind of acts as a wrapper around it, because you probably have no idea what the data scientists are doing. You just you don't want to mess with it, but this is a way to kind of get around that and get the pipeline going. And you also have control over what branches and paths you want to trigger for this pipeline, which is one highlight about it. And another feature I wanted to talk about is the variable groups. You can see here the variable groups can be set up through DevOps really easily, and that's if you want a more configuration-driven development approach. And yeah, now for the actual demo part of the demo. I am in VS Code here, and I have a change that I've got queued up already. So I'm going to commit this change, and I'm just going to put demo. Right, yeah, please do it. Okay. And then I'm going to push, which you shouldn't forget, which I have before. And okay, yeah, I think it's going. So now if we go over here, we can see that it is starting, yeah. Yeah, so it's working, and this takes a couple minutes. So instead of making you wait in silence, I'm going to hand it off to Ron now, who will expand more on this topic. Thank you.
Thank you so much, Echo. Really appreciate it. All right, let me know when you can see the screen if anybody could.
Looks beautiful, Ron. Looks beautiful.
Thank you. We're back to slides. I know the demos are exciting, but we're back to slides for a minute while that demo is running. Thank you so much for getting that kicked off, Echo. So let's get started with, we can skip over this slide. It's a little just intro slide. Let's see some meat here, right? Let's get into some stuff. So Lee eloquently described the problems that we face, the challenge that we're seeing here, why this, isn't exactly solved by our traditional software DevOps. It's not exactly solved by the data ops that David presented in the earlier session. This is kind of its own thing, right? It's its own MLOps thing, right? Part of it's the people, part of it's the process is different, part of it's the tools are different than what we're used to seeing, right? So we're going to touch on a few different aspects of that, particularly here on the continuous retraining cycle, which is, most of the DevOps engineers or software engineers on the call probably, see everything on the left and yeah, that's we know this, right? The stuff on the right, though, in this continuous retraining diagram, this is kind of the new stuff that we're introducing to the continuous integration cycle. And it's all based around the retraining cycle of retraining our models, what Echo actually just kicked off, right? Then we're going to kind of touch on continuous deployment. So just some options, different areas that we can deploy. This is an example. Notice there's tools. The tools are suggestions, as Lee described earlier. A number of these tools can be swapped out. Deployment sources can be swapped out, and we'll touch on that here in a bit. And then the other and very, very important part to, turn our pirates into navies is monitoring, observability, security, auditing, all those good things that are facilitated with the Azure space, with Azure DevOps, and with getting the proper processes in place here. So in summary, we've seen a couple flavors of DevOps: traditional application DevOps, data ops, and now MLOps. So, varieties of spice of life. Let's deep dive here into some of the DevOps parts of the MLOps and the ops pieces as well. So continuous retraining. Continuous retraining is really, it's that CI plus this extra piece, right? As I mentioned, this is the CI is a standard process for anybody not familiar with it. It's the process of automating building those code artifacts. When Echo went into the code, made a little change, committed it, pushed it, that's a standard kind of CI process where the code is pushed, and then we want to merge it with other people's code, or we want to do some other things on top of that, do some unit tests, do some builds. In a proper process, we'd of course have pull requests in place to do code reviews, and all the nice fancy DevOps things that give us low risk, high security, and ease of deployment those don't go away. All of that's still included in the MLOps story. We're obfuscating it a little bit for the demo here. We're obfuscating a little bit for the MLOps piece here, but just know that those pieces are still there and they're still very, very, very important. So the new part and the fun new flavor that we're adding here is the retraining cycle. So this utilizes under the covers Azure ML integrated with DevOps build pipelines. So the key here and the problem that's being solved with this is those developer pushed updates. Something crazy happens, we have black swan events, we have coronavirus, we have just changing cycles. Things change over time. That's how life is, right? So developers need to then update their models and do some retraining after those updates. Historically, that can take a very, very long time just to get out the door, right? Going from POC to production for many organizations can take an exorbitant amount of time. So by simplifying that with an MLOps pipeline and simplifying it with the proper controls in place to make our ops teams, to make our IT teams comfortable, it is an important step here to validating that these models are going to be safe and that we're going to have the appropriate things in place. So this piece is for the dev retraining. There is also another piece to this that's the data retraining, and that's more of a traditional Azure ML kind of style activity that can be done in ADF, Azure Data Factory. It can be done in Synapse Orchestration. It can be done in Azure ML using ML pipelines, or it can be done with your orchestration tool of choice. So just it's APIs under the covers. Azure ML exposes APIs under the covers, and those are triggered by events. In this case, we're covering the developer makes updates events, but those can also be the data-driven events. So what happens after we get all those things together? We get all those built, we get them unit tested. Our data scientists, we have check sign off from our full CI pipeline and our full CR pipeline. What happens next? We want to deploy. And this is the part that's real tricky. This is the part that touches on a lot of the things that David touched on earlier, where we have infrastructure, underlying infrastructure that we need to, and this underlying infrastructure can be complicated underlying infrastructure. AKS is a non-trivial tool to use, for example, or ADF is a non-trivial tool to use. Azure Functions, Web Apps, those things are non-trivial tools to use when you're deploying kind of from scratch. Good news is here with these continuous deployment cycles, we're taking those model deployment files like Lee said, and we're kind of abstracting a lot of that away. And Azure ML actually facilitates deployments to these environments in a way that's ready built for them, kind of giving you that kitchen sink style operation or your 80% operation where you get those initial starters for, say, Docker files, YAML files, things like that for deploying to real-time inferencing clusters or to batch endpoints. So the difference here really between, let's see here, I have a slide later for that, sorry. So this cycle is essentially the same cycle as normal DevOps too. We're laser focusing right now on QA to prod for continuous deployment of an ML model. But in the real world, we need to tie this to other things. We need to tie this to our other code. We need to tie this to maybe our SQL Server updates and DACPack files. Maybe we need to deploy this to our infrastructure as code, our Terraform, things like that to deploy our infrastructure. Maybe we need to tie this to various other steps like GitOps, using for our AKS continuous pipeline here, maybe we need a GitOps cycle with Helm and Flux or something. Those would all be tied into this as an overall pipeline. So touching on that a little bit here, deep diving really into this this area right here of this, where can we deploy to? That's AKS right there, but we can also do batch inferencing. And sorry, this looks like it's on a timer. We can do batch inferencing and we can do real-time inferencing. Those are kind of the two big flavors here. The big thing with batch inferencing is that it's typically cheaper. The idea there is we do some inferencing, let's write it back to the database. We can go or elsewhere, the data lake, for example, too, and then we can go look those up when needed. Real-time inferencing, on the other hand, is doing the predictions in real time, right? That's typically more expensive. It's typically a little bit more complex from an architecture perspective. Things like implementing AKS, you have to also You have to know how to implement AKS, and yes, it's abstracted from Kubernetes on premise because we're not dealing with VMs and all the other, operating systems and stuff like that. We're one layer deeper, but you still have to understand how to operate in Kubernetes environment. So Azure ML helps with a lot of that, but that's still there, and there's still some operational overhead when we're doing real-time inferencing. So if we can do batch inferencing, typically, that's ideal. Obviously, just evaluate the business use cases. Make sure that we're picking the right one. Don't just use real-time inferencing because it sounds cool necessarily, right? Let's make sure that we have the proper use cases for real-time inferencing. And that kind of gets us into monitoring and observability. Okay, so we have these models deployed in secure environments, right? Maybe they're using company data that's secure company data. Maybe they have PII, especially if they have, government use cases where we're talking CGIS data or health data, HIPAA data, ITAR, for example, any number of different classifications there. We have to be very careful about, not just letting those data scientists run wild. We don't want, pirates doing something that would be considered unsafe, whether from a security standpoint or from a, introducing risk to the business decision-making pipeline. Because ultimately, all of these models are going to be utilized to make business decisions, right? So a couple topics here. We had a session yesterday with Lynette who covered security in depth. We're not going to go too in depth into security, but did want to touch on a few things to note when we're considering our Azure ML model development and how it can enable monitoring and observability here. One key piece is poisoning. And that's the idea of introducing bad data into a model and it's kind of the idea of garbage in, garbage out, right? If bad data is coming in, you're going to get bad predictions coming out. That can happen from nefarious sources. That can happen on accident too, right? So important from a security standpoint, we need to make sure that users don't have access to the base data sources in order to introduce bad models that will affect our predictions. Everybody's probably aware of the story of Tay on Twitter, right? That was fed some bad data and it started saying some less than politically correct things. There's other examples like that where models have received bad data and then they started saying bad things, for example, right? So control your data. That's very important. Have data quality, have data classification, all that good stuff. Monitoring and observability is another topic here. It's very, very important. The two are interrelated. Observability is the idea of exposing the data that needs to be exposed in order to do monitoring, right, essentially. So in your models, you need to expose the right metrics. You need to make it able to be monitored. You need to have everything out there so that you can have the proper command and controls in place as an ops team. The monitoring piece is we have to have ops. Eyes on screen don't go away necessarily, right? Yes, all these PaaS platforms facilitate. Yes, we want to automate as much as possible, but no, that doesn't mean our ops teams are going away. We're just making our ops teams more efficient. We're letting them focus on bigger things, on enabling larger sizes, on managing those Kubernetes clusters, like I mentioned earlier. So slightly more complicated tasks, giving them more work from a production standpoint without focusing as much on the nitty gritty. You don't have to have eyes on a dashboard every day monitoring your model to see if it's correct. We want to automate that as much as possible and then automate responses and alerts. So that kind of ties into proactive solution management here. And this is really important because ultimately, like I mentioned earlier, we are serving up for business objectives. If you have a predictive model that's predicting something that's critical to your business, the best case scenario here is to proactively get ahead of any issues that could occur, whether they're security related or whether they're related to bad data coming in from just data sources change over time, or whether they're cyclical environment driven like COVID or like ice cream sales, that type of thing, right? We can get ahead of those utilizing with proper monitoring and observability that are facilitated with the Azure ML Workspaces and facilitated with some of the metrics that Echo is going to show here at the end. A very simple example, but an example nonetheless, and they obviously get much more complex. Lee, did you want to touch on model drift real quick in comparison with ground truth?
Yeah, sure. So observability, then, this is the idea now of more themselves and their inputs and their outputs. And this really comes in two flavors. And this is really more on the model outputs, right? What are we getting out of our model? One is sort of concept or model drift. So this is concept drift is the inputs changing over time, COVID, ice cream sales. Model drift is, out of these things come numbers, right? They come, forecasts or come probabilities, are the normal things that come out. Are the distributions of those numbers changing over time, right? The red to the blue in the picture that I'm showing here, right? And these are great because they're quite general, and some of these things, like it's not that hard to monitor looking for drift. It's not trivial, right? But it can be automated with the right sets of tooling and the right skill sets. But that's less efficient than the other flavor, which is comparison with ground truth. So the ground truth is what actually happened, right? So we can say, well, our distributions are changing, but they might still be accurate over time. This is saying, okay, well, over time I accept, and this is on the two plots there, the left-hand plot. So that if the model doesn't change over time, my accuracy and quality are going to go down. Okay, the outcomes are going to get less correct with my predictions. By refreshing it on the right-hand side, we can offset that. This is then just retraining the model without a code change, right? Just with a data change. The challenge here, though, compared to the first piece, is that it's use case specific. Right, the metrics we use to monitor this differ based on use case, and also some things like, let's take the scanning trucks example. That's IoT sensors. You get immediate feedback from those, right? If you're predicting badly, you'll know pretty quickly that you've made a bad prediction. But let's take a marketing campaign, right? And you've predicted a marketing thing. Typically, it takes 2 to 4 weeks. Well, it depends on the use case, but 2 to 4 weeks is a typical time frame to get feedback on a marketing campaign success or failure. So in those cases, you kind of can't really do ground truth there and then. You've got to wait 3 weeks to a month till it makes sense to do it. And that variability of time there also makes things very hard and use case specific. So that's observability in a nutshell.
Okay, so real quickly, touch on some, again, apologies, touch on some unique attack vectors for machine learning here. Okay, this is gonna work this time, I promise. So there's a few different. Okay, that's frustrating. Here we go. Okay. We will just do this the old-fashioned way. It's not a tech demo unless there's technical problems, right? So unique attack vectors for ML. There's a number of different ways that you can get in here and cause problems outside of just poisoning the data sources. Some of the attack vectors include typographic attacks. So sticking a piece of paper on an apple and calling it an iPod. No, that's a Granny Smith apple. That means there's probably some issues there where somebody just introduced something, they knew how the model was, and they introduced something into the physical world that caused problems for the model, right? Poisoning attack here, we kind of touched on that, but touching on it a little bit here in real life, where you can come in and change the actual the data underlying for various things, where you can change a sensor, for example, to view a stop sign as a speed limit sign instead of viewing it as an actual stop sign. Adversarial attacks, this gets real deep into the actual math under the covers. I mean, if you notice here on the left, we have a picture of a panda, and to you and me, the picture on the right looks like a panda as well. But if you'll notice here, what happened was there was some noise introduced. And this noise was introduced in a very specific pattern that made it able for us to still see it, but a computer model is not able to detect that this is a panda, right? There's a lot of different algorithms under the covers for doing image detection, and those can be exploited by doing relatively simple things like this that are kind of difficult to attack. So it's important then to make sure that we have the appropriate command and control in our environment to prevent these things from happening. We don't want somebody to be able to overwrite one of our blob images with static or with extra edges that want to be visible to the human eye, things like that could cause difficulties there. So in kind of summary here, the key point is that MLOps and DevOps aren't that different overall. There's some different pieces of them. It's a little bit trickier. There's some, it's a little bit closer when we're talking about the business objectives direct to the IT objectives, as far as enabling business users to quickly get updates from their data from the underlying systems and the underlying data integration platforms, as well as responding to them with developer events. So when we're kind of viewing it as what's the difference, right? What's MLOps versus DevOps versus data ops? MLOps is the same thing essentially. It's just, from my perspective, maybe a little bit selfishly, more important, right? You're much closer to that end goal, to making those decisions and reacting to them quickly. So just to finish with a bit of an example here of a roll up, if my network has a critical issue, due to, let's say, an unprecedented deep freeze in Texas, shutting down one of our on-premise data centers, all of that would cause a delay in ingestion. So I'm the hero then if I can proactively notify business users that the systems they rely on for critical business decisions are not currently effective. And then I would need several things to really operationalize that. I need observability from the ML models. I need multiple layers correlated into a single platform. Azure Monitor is a great tool for that, log analytics, solutions like that. And then I also need to correlate metadata from a data catalog such as Purview to reference my data owners, my business users, the criticality of the data, and possibly, if there's any security breaches, right? Power goes down, unprecedented events, there could be issues. I need to get on top of that quickly and proactively. And MLOps really enables us to hit that real quick. If we need to make a developer update because we're seeing issues, because we're getting unexpected values due to poisoning, typographic attacks, adversarial attacks, anything like that, we want to respond to those as quick as possible, get developer updates, lock everything down, and then start providing business value again. All right, Echo, over to you to kind of show everybody that the model's not all smoke and mirrors.
Okay, yeah, it's finished just in time, actually. So let me share my screen again. Okay, yeah, so I'm not going to pretend to be able to explain this nearly as well as Lee would, but yeah, so this is the Azure Machine Learning Workspace, and here we can see the steps that the model went through. It did pre-processing and then the training, which is now complete. And then it output this curve right here. It's an ROC curve. It's a binary classifier. So it's receiver operating characteristics. So basically you want the area under the curve to be maximized. And I know that is good. It means that our model did a good job of, figuring out what was what. And here is another measure, which are the metrics here, which, like I said, I know that AUC stands for area under the curve, and that's about it, but Lee can probably go into more detail there.
I didn't even know that, so now I've learned.
Yeah, and the key thing here as well is that what we like to see when we do a model update is that our metrics are as good as or better than they were before. Right, so the real goal here is that now we can know that model's been retrained automatically. Great. When I look at these metrics and say, well, are these better or not? Because if they're worse, that model isn't a good model. So we'll just roll back immediately before we even deploy it out to our infrastructure. Right, you definitely want some quality checks, model quality checks, in between that model retraining, that CR, continuous retraining phase, compared to the C. And that can be automated, right? It doesn't have to be a human in the loop. It can be, but you definitely want those checks to be in place as a pipeline as well. Don't just don't never deploy naively. It's a good rule of thumb here.
All right, are there any questions for the team?
Ron, do you want to go through the survey? There's I think a couple more slides into that deck to roll that out.
I'm getting it up right now.
So shameless plug for ourselves here. So we're now quite good at this. We've done it for a few of our customers, and we now offer workshops around this. So common questions could be, am I ready for MLOps? Do I need MLOps? How do I get started with MLOps? What's the first use case I should get to production with MLOps? We can help people to make those decisions, both by assessing your current data science or analyst workflows and your current Azure infrastructure, and help you figure out kind of what the right priorities are for getting this working. And if you have any gaps that need to be filled, we can help provide you a roadmap for that as well. So we'd love to have you on for one of those. There's a survey here. I believe there are 2 gift cards, and every time you do a survey, you get an entry. So if you do all the surveys, you get all the entries, a bunch of entries. So please do let us know how we did. We'd love the feedback, but please be nice. And yeah, I know there've been some questions in the chat. Does our moderator want to pick out some fun ones for us? And if you have any more, just stick them in the chat as well, and we'll answer them. We've got plenty of time.
All right, let me go read one here. Are there additional concerns with deepfakes or other types of disinformation and compromise of training data or other aspects of data being used in ML?
So that comes down to the poisoning piece. So potentially you could choose to poison someone's data by uploading some deepfakes into it, right? And deepfakes are an example of something called generative learning. So it generates new content, new information, i.e. a new face on someone's body, or indeed, creating something, making someone's body digitized. And if you say had a model that wanted to predict, who a person was, so facial recognition, which by the way, I would never recommend you do right now. The technology is not to standard. It is not good enough for modern use cases. It's too inaccurate and it's too biased. Deepfakes would have went like that. But if your model was say just to predict, can I recognize can I count the humans in the room? Can I count the humans here? That might be less of a problem. But again, then come out that there's adversarial attacks. Can the deepfake be manipulated so it can do an adversarial attack? So the key takeaway here really is make sure that no one can upload deepfakes to your trained data location, which is like back to that security concern. Lock it down. Only give people access to it that need access to it. Yeah.
Okay.
Ron, anything to add to that, Ron?
I think you hit the nail on the head.
All right. What are the key differences between MLOps practices and DevOps practices and skill sets, and how can we quantify if we really need these, if these processes are really necessary in our organization?
That's a great question. The key differences between the practices and skill sets are primarily tied to, again, that's continuous retraining piece that we mentioned earlier, and understanding the inner workings. The more abstract this gets over time, not to wax philosophically with y'all, but the more abstract a lot of these processes get and the more that's automated over time, the more we're probably going to see, this kind of process being automated, being simplified to a situation where there's not much of a difference between DevOps and MLOps necessarily from an overall process and perspective, process and practice perspective. Maybe a little bit from the tools perspective, where we still need a data scientist in the equation. But the same thing can be said about, front-end development and back-end development. 20 years ago, it was, real difficult to be a front-end and back-end developers because the tools weren't necessarily there, the abstract layers weren't there, the JavaScript libraries weren't there necessarily to do a lot of the things that now are considerably easier with middleware activities, with things like that, to where now, a full stack developer, it's not as difficult of a task because a lot of the abstractions make it very similar using, say, .NET Core and MVC or Angular or Knockout or anything like that. We have the same patterns and practices between the two. So that being said, right, there's not really much of a difference, and over time, I think that they're probably going to be more similar. Right now, it's a deep understanding of the models, of the business objectives. Is it batch? Is it real-time inferencing? Those types of decisions are, you know, a little bit difficult to make unless you have a full understanding of the overall solution architecture.
And in terms of the question, the part of the question that was, do you really need it? The answer is it depends. If you're an org and you only have one model in that you're using, and you're kind of okay with it on someone's laptop and all the overhead that brings with it, you probably don't need this, right? You know, the effort required to do this probably exceeds the value add that you get back. But if the model is in any way business critical or needs to be updated regularly, or model, right? The overhead grows per model, you know, and often it doesn't scale linearly. It scales worse than that if you're doing it manually because all the context switching. At that point, you really should start looking at this very, very seriously because it can be a massive time saver. And yeah, if things change quickly, a massive lifesaver as well. You know, a lot of organizations still take 2 to 3 months or more to do one update of a model to production. That's not uncommon. In fact, several take more than a year to do it, to go from the lab to production. And that, you know, just you spent all this money on R&D on data science. If you can't get it to production quickly, you aren't getting the ROI that you want and need. You know, you aren't getting the ROI for the investment that you've made, and therefore you aren't getting the value you need.
One other kind of piece of this equation that we didn't touch on that much in this MLOps session is pre-built models like cognitive services. Say, for example, when we start pulling in some pre-built models as opposed to building full custom, those situations really put that needle closer to the DevOps perspective, where they're effectively APIs or infrastructure as code under the covers, and APIs are standard classic DevOps. Infrastructure as code is essentially classic DevOps. David did a wonderful demo of it earlier. And when we start kind of making those decisions and deciding if we need MLOps, we don't necessarily need it if we're mixing in a lot of cognitive services, but if we are utilizing our own data scientists with our own custom models, that's really where they come into play. And it's not necessarily an either or either. A lot of times we like to stress you use both, right? Don't reinvent the wheel, but use the wheel to build the cart and to build the motorcycle and then build the airplane. And well, you don't need wheels on a rocket necessarily, but you get the idea.
And there's actually a session on that at 2:30 Central Time. Our colleagues Roy Concepcion and Michael West are talking on literally how you integrate those cognitive services, those pre-built models into your existing apps to make smart apps from a developer's perspective. So plug for them. It'll be a great session.
Just to add on to the question about the differences between DevOps and MLOps, I think an important thing to note too is just the nature of machine learning, just data science, how it works with trying different features and parameters. And I feel like that differs a lot from a traditional developer workflow because there's a lot more iterations, and there's also a need to create these reproducible results, which is unique, I think, to data science as opposed to from a developer's perspective.
And I'll be frank as well on Echo's point there. Like a lot of data scientists, like I'm fortunate, like I've been in the field long enough that I had to get reasonably good at coding because back then I had to build my own front-end apps to deploy my models with 9 years ago. Whereas now the barriers to entry are a lot lower because the data science tooling is much better. That also means that a lot of data scientists are piratical in their code practices as well. A lot of data scientists don't write great code. A lot of it isn't testable. It's not well modularized. And that does create some challenges too for the deployment, because if you recode it, well, then they can't maintain their own code, right? Because they may lack the engineering skills to do so. Then how do we, and this is what we try to do ourselves, is wrap around what they give us, as Echo showed, to kind of meet them where they are. But that can be difficult because sometimes we get some code that is, it works, but can be hard to deploy.
All right. Any last questions? Otherwise, we'll take a 5-minute break and start with the Powering Smart Devices session in 5 minutes.
And I love how I ended that session just trashing my own field. So thanks, everyone. I appreciate it.